Oh my goodness, my microphone was off. Oh my goodness. All right. Hello and welcome to today's live session. Okay, I need to do something here. Mute that. All right. Hello and welcome to today's live session. Today we are going to talk about performance of, performance in mobile apps, in performance in mobile app development. Oh my goodness. So, let me just see. For the first time, I have prepared slides. I normally just, you know. Now, why are you displaying on the wrong screen? My goodness. Okay, it appears. No, I thought I was sharing this screen. Okay, there we go. So we are going to talk about performance, reliability, and security in mobile app development. Now that we have AI, we shift our focus from learning about the syntax, knowing what to type where, knowing how to write an array or write a list or write a variable, to what really matters when we develop software. And three of the most important things, and I've been talking about this for a very long time, is performance, reliability, and security. If your app is fast, if your app is reliable, if your app is secure, nobody cares how you built it, whether you vibe coded it, whether you generated it with what. Nobody cares. We only care about these three things. And to start us off, I want us to look at this video. Okay, let's look at this other one. Where is it? Let's look at this other one. Oh, I have to hit play. Okay. All right, and let's look at this other one. Where is it? This one. All right, so there's one common factor, or there's one thing common between the two videos that we have watched, and that is the animation is smooth, or maybe let's say just how the app performs. It's smooth, it's fast, there's no flickering. You don't see something flickering on the screen, you don't see something shaking on the screen. Everything moves smooth and all that. But before we dive deeper into performance in the app, let's look at what a mobile app does. So let's just draw a mobile app here. So this is our mobile app. We have quite a few things. We have, maybe let's say, this section. We have another section here, maybe for displaying images and whatnot, like so. Let me see. I forgot how to draw. All right, so we can have something like that. All right, and we can have a bunch of text down here. So to simulate a bunch of text, I can just do, oh my goodness, no, don't duplicate like that. So let's say we have a bunch of text down here, and we have our little nav bar down here. Our nav bar will have nav link. So this might be home, about, contact us. Okay, in mobile apps you don't do that. Profile page and whatnot. So what does a mobile app do? Let's start with the very basics. Number one, you open it. So we'll have another, so let's just simulate something like this. So assuming it's story up, all right, assuming it's story up, so the first thing you'll do is you will click on the icon, or story. So we have story up here. Why are you snapping? Why are you snapping? Oh my goodness, you're not supposed to snap. Okay, I don't know why this thing is snapping. I don't know why it's snapping. Okay, there we go. So the first thing you'll do, of course, is you will click the icon to open your mobile app. So you click the icon, it opens the mobile app. So if it's like, for example, Facebook, you have posts, you can see comments, you can see reels. If it's WhatsApp, you'll see the chats, the statuses. You can scroll at the bottom or at the top, wherever the navigation bar is, and do a lot of things. So the first thing an app needs to do, it needs to get data from an external source. It needs to get data from your API. So we can list here the things that an app does. And if you're just joining us, welcome. We're just getting started, so you'll not get lost. We are basically just listing the things an app does. So things app do. Let's call our list this. So we can just put it there and scale it a little bit. So we can say number one, it fetches data. Number two, what does it do? It stores data locally. Number three, sends data to the API endpoint. Number four, calculates something like what? It calculates discount. So something like discount. A mobile app also fetches the location. In this case, we'll say GPS. Oh my goodness, how do you write coordinates? Coordinates. Yeah. It fetches GPS connections. What else? Coordinates, not connections. What else can a mobile app do? A mobile app can attach a photo. It can view a photo or video. All these things a mobile app can do. So what does all this have to do with the performance of a mobile app? Again, we'll make another list here. We will say this is factors affecting performance of mobile apps. So let's just say mobile apps, because I'm trying to be fast. One thing you will notice about how I do my live sessions, and you've come to a few of them, I rarely prepare that much prior to my classes. It's because what I always want you to do is I want you to have a raw experience of what goes on under the hood, not under the hood. When we talk about building apps, what exactly are we doing? So I want you to go with me, see the errors, see me fix the errors, and so on and so forth. So the downside of that comes with this, because now you have to sit there and watch me write some notes. So we have network connection, factors affecting the performance of an app. If I forget something, just type in the chats. What else? We have CPU. We have memory. And what else affects the performance of mobile apps? CPU, memory, battery. Okay, not that much. Battery doesn't really affect the performance, because if you are at 30% and you're at 40%, your app will just perform the same way. But you can just list it here, so that we don't get lost. Now we are going to put this in. Oh my goodness, no, this was supposed to be in a different section, so that I put them in red. Right? So CPU, memory, and battery, these are factors affecting the performance of a mobile app. We'll put it like that. So you ask yourself, how does the network affect the performance of a mobile app? Your mobile app fetches data all the time, and your mobile app is connected to some form of a router. So you can have Wi-Fi connection, you can be connected to hotspot, and so on and so forth. So if you're using Story app, your mobile app will need to fetch data from the API or from the backend, and it will look something like this. So let's assuming you're fetching data from the server, and we can have our server right at the top there. So we can say this is the server. So we can say backend server. All right, so your app will fetch data from the backend server. Now, if you are connected to an internet, let's say for example 30 Mbps, so that means if the data you're fetching is 30 MBs, you will get that data in a second or less. If it's, let's say for example 5 MBs, you'll get it in less than a second. If you are downloading data that is, let's say 60 Mbps, then that means roughly it will take longer than 1 second. I don't know how much it will take according to that math, but it will take roughly longer. Now, here's the interesting bit. If the user is querying, our API endpoint has how many users? So let's say our backend server has 1 million users. All right, 1 million users. 1 million users on Facebook. If we are querying a list of users, if you are on Facebook and you search, all right, you want to search for Moses Mbadi, will the system go through the entire list and recommend? Because if you notice, when you're searching on Facebook, it shows you potential matches of the name you're searching. So will the system go and fetch all the 1 million users and show you, or will it just show you maybe 100 users? All right, so that brings us to a very important question. When your users are fetching data in your mobile app, are you showing them the data they need to know only, or are you showing them extra data? Assuming this user is on the profile page, so we can say this is the home page. This is the home page. Put it there, and we can also have an extra profile page. All right, and the profile can look like, let's try to create a profile page. So the profile can have the background, it can have the profile image, you can have you can have buttons right here, follow buttons and whatnot, and things like that. And then you can have the name. You can have the name and then more information here, and then you can have more sections down here. So let's just change this to black. So if a user is fetching information about their account, and the user has written a couple of stories which you can display at the bottom here. So when you're querying the data from the database, how much data are you giving to the user? Are you sending to the user? Are you sending, let's say for example, if their profile has, let me see, I cannot type inside here. If their profile has a name, let me just delete that, it wasn't a text. So if their profile has a name, age, year of birth, reads count, let's say for example monthly reads, followers, what else does it have? For example, bio, contacts. All right, so let's see. So when the user is, what have I done? My goodness. When the user is in the home page, where we only need to fetch and display the author's name, who posted that post, we only need to fetch and display the name only. So here, will you query the backend server for all the information available to that user and then only pick the name, or will you query the name only? The same applies to if you are querying for the profile. So you're querying for the profile. how much information do you need to query from the server so that you can display in this page? So that is one of the things to look at. So network affects a mobile app performance in two ways. One, the speed of the, maybe let's say, router or mobile data the user is connected to. Number two is the amount of data you're sending. So if you have an endpoint, and we looked at creating endpoints in the backend. So if you have an endpoint that does something like profile, me.profile, and then it does something like other profile. All right. So does this change when you're querying data in the home page, or does it remain the same? Because remember, in the home page, we only need the author's name. We don't need their age, we don't need their followers count, we don't need anything else. That we can figure out once we get to the profile page. The other thing that affects performance is CPU, and we look at CPU in more details when you look at rendering and how your computer is supposed to draw items in the screen. But I'll give you a preview of what happens. So we all know, let me just again copy this somewhere else. So your mobile screen uses what you call RGB, which is basically dots. You know, when you zoom in, you can, when you move closer to the screen, you can see which is basically dots that have colors. RGB. What does RGB mean? Red, blue, green, I think. So that is the language your screen understands. That touch screen you're touching, that is the language it understands. It does not know what a button is. It does not know what a text is. It does not know all those things. So if you have a button, for example, so let's say this button is for buy now. If you have a button, or if you have an image, I don't know what I did, because this thing is snapping and I don't like it. I don't want it to snap. So let me see. Let me just drag an image in here. Let me get an image. Where is that image? So let's say we have an image like this, and somebody wants to buy the laptop, and it's an e-commerce shop. So you have to show the laptop and you have to show the buy now button. Now, to a normal user, all you will see is, let me see, all you see is the laptop image and the buy now button. This is what you're seeing on the app. However, the screen, for it to display the dots, it has to convert the image. Let me just do this. It has to convert the image and the button to a language the screen understands, which is dots and zeros. And it does this using the GPU and the CPU. So they work together to see what is displayed. That process is what we call rendering. Basically, that's what rendering is. Sometimes when you're reading, it can sound a little bit too complex, but let me see. Is this loud enough? Because I want to move it here. But that's basically what rendering means. It means the process of your your phone goes through to convert text, buttons, vector-based shapes, and images into the tiny dots on your screen, the RGB dots. Am I saying that correctly? I hope I am. Yeah. So basically, that's what happens. So that means if you are rendering a lot of content on your screen, if it's in your, let's say for example, in your product details, a user is looking at this product and you want to display other products on the screen. So you will have, maybe let's say for example, houses, and you want to display houses on your screen at the bottom here, and you know, more options or whatever. So you have 4 images here that you want to display at the bottom. So how much work will the CPU have to go through, or maybe to carry out, the CPU and the GPU, how much work will they have to perform for the display to work as it's showing right here. So again, that goes back to how the CPU affects the performance of a mobile app. So you would imagine a CPU with, let's just look at some random figure. I'm not saying this is actual. So a CPU with let's say 1 gigahertz per second and a CPU of, let's say, 2 gigahertz per second. If they are rendering the same content, on the screen, this one will obviously perform way better. And that's why older phones struggle a little bit. So if you have an older phone and you're trying to use WhatsApp, Facebook, you'll see it struggling a little bit. But for a newer phone with a higher CPU, you'll see it, it will be smooth. There'll be no flickering, there'll be no sluggishness. Everything will be smooth, as I showed you in the videos that we looked at. So that's one thing to keep in mind. Now, why is this important? If the process of displaying this image on your screen consume more CPU than the process of displaying this button, then that means there will be some sluggishness in your app. Your app will be a little bit slow because the phone has to go through so much work for it to display the image. So you might be asking yourself, how can that happen? That happens when, let me just show you. Let me just go to this website called Pexels. So you're using this image in your mobile app. You want to display this image in your mobile app. So you want to download it, of course. When you go to the download section, if you click on this, you can see we have quite a few options. So we have this and that. So let me just download them. So I will download this size and I will download this size right here. So I will bring those two sides into my whiteboard here. So let me see. So I'll bring them inside here. Oh no, I'm opening instead of just dragging them. I'll bring them inside here. So even without doing anything, if you look at the sizes of these two images, they look different. One is bigger than the other, all right? And as you can see, just visually by looking at it, they are already too big for our screen size. So if you have these two images, so you have this, let me just resize them manually and then put them here and then do this again and put it here. All right. So if you have these two images and you want to display them in your mobile app, right away, this one will take less resources to display. It will take less resources because, as you can see, it is the size. We call into size, okay? Because if you just drag the image into your viewport, as you can see, it fits inside very well. Of course, you might need to expand it a little bit. What if you want to use this image? If you want to use this image, you'll have to do some extra work so that the image fits on your screen or on your viewport. Oh, this one fits, so this one is good. This one has no problem. But if you want to fit this one, your phone will have to go through so much work for it to fit inside that display. Furthermore, going back to the concept of network connection, this image is bigger than this one in terms of size. Let's see if that is true. So let me just zoom in. So if you look at this image, let me see, properties, where is properties? This one is 36 kilobytes. If we look at this one, properties, this one is 918 kilobytes. It's almost 1 megabytes, right? So that is one thing to consider. Now imagine you are fetching stories for your mobile app. You're fetching, let's say, 10 stories you want to display, or not really stories, you're fetching items, all right? So each item will have a name. Why are you not? So each item will have a name, it will have a price, it will have color or whatever, it will have location, and it will have, let's say, an image. And images can be as you have seen in apps that sell items such as Gigi and whatnot, we don't just display one image. You'll have the main image, so image 1, image 2, image 3, image 4. All right, so this is the data we get when we query one item. Now let's look at how not optimizing the size can affect your performance. So if each of these images 1 megabytes, 1 megabyte, oh my goodness, what am I saying? All right, so 1 megabyte, and then the last one 1 megabyte. So the total size of this data will be 1, 2, 3, 4. So it will be around 4 megabytes. All right. So what happens if your images are more than, if one of your images is more than 2 megabytes? So you'll have, let's say 3 megabytes, and then maybe this one has 9 megabytes. So the total size of your payload will be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It will be 19 megabytes. All right. So as you can see from this one is already bigger. If somebody is connected to an internet which has 2 megabytes per second, let's look at what my internet speed is. Speed test. Let's look at my internet speed. That's a lie. By the way, can anybody tell if my screen is flickering? Because I see a lot of flickering on this other screen. I'm sorry, I couldn't get my usual thing to work. Anyway, 24 Mbps. So if I am fetching products and each payload has this size, how much will it be to fetch 10 products? Yep. If I'm fetching 10 products, then I'll be working with at least about 140 megabytes. Of course, I have not said 19 times 10, and I'll leave you to figure out why. You'll be working with we'll be working with 140 megabytes. That is quite huge, all right? That is quite huge. My app will be a little bit slow and it will be a little bit sluggish. So that is why this has nothing to do with your mobile app. This is entirely on your backend. So your backend is responsible for making this payload smaller. You don't have control over the size of the image the user is going to upload. If I want to upload a post right now and I'm uploading an image taken by a camera, a sophisticated, okay, not sophisticated, but just a camera, the image will be, say, about 20 MBs. Now, you don't want to tell me Facebook will store 20 MBs for every user, millions of images being uploaded every minute on their servers. That will be crazy. It will be crazy. I don't think they'll be able to sustain that kind of storage. So Facebook does some little bit of what do we call it? They resize your image once you upload it, and they resize your image for this specific task, for this specific purpose. If you've also tried to view somebody's profile on WhatsApp, you'll notice that at first the image appears a little bit blurry, and then now it appears the higher quality version of it. That's basically because the data Facebook wants to send you at first for that screen you are on needs to be very small. So we have looked at network connection. We have looked at how CPU affects your performance. Now let's look at memory. How does memory affect your performance? It goes back to the example I was giving you with the CPU, because as you all know, the CPU needs memory to store the data and the instructions it's performing to that data. So again, it goes back to this. If you are loading an image, 19 MBs in size, and the CPU has to draw that image, actually, when you're writing code in text. So you're saying screen size 20 megapixels. The CPU needs to understand what you're saying. It needs to take that code, convert it into something it can draw on the screen, and I'll show you that in a second. So if I'm sending 19 megabytes of data to the CPU, then that means it will need 19 megabytes of memory so that it can store the information there as it processes. So that means if you're sending more data to the CPU, more data is being stored in memory, more data is being more memory is being used. That leads to your app becoming slow. Some phones will even kill your app. You'll find your app crashing and things like that. Battery, not that much. It's just that if you have a poor battery and your phone is using a lot of CPU, not that tool, and your phone is using a lot of CPU and a lot of memory, then that means your battery will drain faster. All right, so you can go to your phone to battery usage and look at the apps using the most battery and all that. So just by going through what I've gone through here, we can now understand everything your app needs to do. Your app needs to draw on the screen. Your app needs to fetch data. Your app needs to store data, while it's processing and all that. All right. I think I did digress. Anyway, back to our PowerPoint presentation. So, let's see. Play this thing. Again, I have to switch. All right, so we've looked at how smooth this is. We've looked at how smooth the other one was. Again, just to go through what I've said, RAM, battery life affect the performance of your app. So there are 4 universal pillars of performance, or things you can use to gauge how fast your app is. So we have rendering. Do you see that thing called 60, 120 FPS? It's what we call frames per second, which basically means it's that drawing on the screen that I've shown you. How many frames is it drawing per second? So some draw at 60 frames per second. So you cannot really see because it's too fast. So it draws 60 frames per second. And, some draw 120 frames per second. It's interesting, actually. You see, videos, they are just images stored in a sequence. That's basically what videos are. Even when you're shooting a video, you're not actually shooting something continuous. You're shooting a lot of images per second. So even in your camera, you will find such settings in some phones where it asks you, I think it is here. Let me see if I have that feature where I specify how many frames per second do I need. Here, so if I have video turned on, as you can see at the corner here, it shows that I'm shooting at 30 FPS. You might be wondering, what is that FPS? It's frames per second. So if I click on it, I see I have 30. I hope I'm not recording myself. As you can see, I have 30 and I have 60 frames per second. So 30 is more natural, the natural world, as things are moving and whatnot. It's about 30 or 25 frames per second. So that means 25 images will be captured in 1 second, so that to create that loop. So that is just something interesting to note about frames per second. And then we have memory, which is RAM management. And then we have threading, which is basically how much information can the CPU handle at one go. And then we have network. And I've already explained to you how network can affect the performance of your app. By the way, all these things, nobody has, no app is perfect. Like, it follows all the pillars to 100%. If you have downloaded Story app, you can see in some screens it's a little bit slow, it's a little bit sluggish, because in as much as network performance is important, you also have to remain sustainable. You can't deploy your application to a server where you need to pay 10,000 a month and you're serving 1,000 users. It won't make any sense. This is again things to do with the frames. So if when you talk about frame dropping, if your frame drops, then your app flickers. or it becomes sluggish. So and again, these things, you don't really have to master them. You don't have to understand exactly what this is and you know what it does, because if you build an app and you tell whatever AI agent you're using, I want you to maintain my rendering at 60 frames per second. Or you can even ask it to scan your code and identify areas where frames might drop. It will tell you. It will tell you frames are dropping here, frames are dropping here, and it will even give you the reason why your frames are dropping. So that is all you need to do. You need to know your app should never drop a frame, because if it drops a frame, then there's a gap, and that is where the flickering comes in or the sluggishness comes in, and things like that. So this is just a very complicated AI generated image that explains the entire process, you know, what happens. All right. So if you have, let's say, for example, an object, hello world, and you have given it the size 16 padding, whatever, and you have an icon, your phone will have to go through all this process. And you would imagine this has to be very fast. Because you only have 2 seconds to impress anybody using your app. Right, so your phone will have to go through this entire process. It has to measure how much, how far am I drawing on the screen. So it has to convert the vectors or rasterized images, don't worry about that word, into pixels, and then these pixels can be drawn on the screen. Like I've said, this is what your screen understands, pixels and, you know, the RGB dots. It does not understand text. It does not understand hello world. It does not understand a profile image or a profile icon. And then now that is what now gets, you know, drawn on your screen, right? So in terms of memory, like I've explained with the example I've given you, you want to use as little memory as possible. So if you are fetching profile images or product images from the backend, which image are you fetching? In certain backends, whenever a user uploads an image, it's normally processed and stored in 3 or 4 or 2 versions. So you have the first version, which is super small. It could be even as small as 5 kilobytes. And you have another version, which is the original version, the original high clarity version. So when you're browsing through WhatsApp and you look at the profile images, all right, and you look at the, no, I'm not showing you guys my WhatsApp. Anyway, you get what I'm saying. If you're browsing through WhatsApp and you look at the profile images, they are very small. So there is no need for you to fetch the original image and display it there. It becomes a lot of work for the phone to understand and to calculate and to print on the screen. So first you send the preview image, which is smaller, and then when the user clicks on that image, so that means they want to see the full image, you can now fetch the full image and display it, you know, and things like that. So that is one of the things that separates an app that has been built by a professional from an app that has been built by maybe, let's say, a student, because a student will not pay attention to such things. That's why you see the app flickers, the app is buggy, and all those things. So now we talk about the concept of threading, and this is so complex to explain. Let me just pull my notes. I did write some notes for this one, so let me just pull my notes here. What are we talking about? We are talking about threading. So basically, and I'll try to explain this in a simple to understand way. So let me even do away with the notes. So on your phone, anything that does any processing, like I've said, your CPU has to process how much information it needs to draw. How much information it needs to draw on the screen. So for the CPU to process all this, it has the concept of threading. It has the concept of threading. Does that even make any sense? It has threads. Threads are what you call, threads are what performs the tasks. So inside your computer or inside your phone, you have the main thread which handles everything important. Like for example, clicking a button, making a payment, that is handled by the big boss, which is the main thread. And then it has background threads. So what these background threads do, they handle anything that is less important, because the background threads can sleep, but the main thread cannot sleep. So we can give it an orange. So the main thread cannot sleep because it handles everything important while your app is running. It handles the button clicks. It handles the receiving, for example, if you're building an app that handles phone calls, receiving a phone call, anything important is handled by the main thread. So I realize that sometimes I talk too fast that I lose you guys. And that's why when you're starting this course, I started with almost 100 people in my live stream. Now I only have less than 10. It's because I talk too fast. So let's take a step back and understand what threads are. In any operating system, how the operating systems performs your instructions, it uses what you call threads in the CPU. Your CPU has threads. Threads are those tiny things that perform instructions. So threads are divided into two groups. You have the main threads and you have the background threads. The main threads never sleeps. It remains running 24/7, it remains running because it handles the important tasks you want to give it. Like for example, turning on the camera, taking a photo so that you can upload, for example, clicking a button like I've said. And then you have the background threads. These ones, they can sleep because they are performing Amir Philip, what tech stack do you use for mobile apps? It really depends, but I prefer Flutter. What? Oh, you're done? You're done cooking? Okay, I'm almost done. So I use Flutter for mobile apps because Flutter is cross-platform. From just one single code base, you can develop apps for App Store, apps for Play Store, and all that. Android and Apple is what I mean. Thank you for the feedback, Amir. So if you have if a user uploads an image, if you want a user to upload an image, all right, and an image takes some time to process because we have to check if it's the correct image. We have to check if it's not malicious, because some people are very creative. They can embed malicious code into an image. Do you give that function to the main thread or do you give it to the background threads? You give it to the background threads. So when you're writing code, yes, just like React Native is also cross-platform. One thing to note though, React Native struggles a little bit when you're working with location-intensive apps. So if your app needs to work with location, GPS, React Native struggles, more than Flutter. So if you want to process an image, you send it to the background tasks, okay? Now here's an interesting thing. When you're using Uber and it needs to show your accurate location, all right? Do you give that to the main thread or do you give it to the background threads? I'll leave that for you to research and find out. All right. So that is basically the concept of threads. So when you're developing an app, you need to identify the tasks you need to perform. At this particular screen or this particular section, when a user clicks buy token or load airtime, how instant do we want that process to happen? Then you can put it to the main thread. If it's something that can happen in the background, if a user needs to fetch and just wait and see the stories. For example, think of Facebook. When you're browsing through Facebook, you will browse continuously. I don't know if you'll get to the end, but you'll just keep browsing continuously. But Facebook did not fetch all that data. it did not fetch all that data and display it for you, because if you scroll, you'll realize there is quite a lot, almost over 50 posts. A post, maybe a reel, which has a video, it has an image, it has multiple images. So at first, when you open the app, Facebook will use the main thread to load the important things, like for example the first 3 posts that you see, and then it will offload the job of fetching data to the background threads, so that they continue fetching jobs in the background as you scroll. That way you'll not even see any flickering, you'll not see any sluggishness when you're browsing through Facebook, and so on and so forth. But of course, Facebook has money, you don't, so you also have to be smart about that. Let's carry on. So that is all about thread management, and it's basically you offload your tasks to background threads. And some of these tasks can be database queries, crypto hashing, image manipulation, and JSON parsing, because as you saw from our previous tutorial, when you're talking about how to connect your mobile app to a backend, you saw that the backend gives us data in JSON. So we need to pass it into a language the mobile app can understand. So each framework or language has its own tools that will help you know where to put your data. So if you want to work with the background threads, in React Native, you'll use this thing. You can Google about it. In Flutter, you'll use this thing. Again, you can Google about it. Kotlin and Swift. I have never written a single Swift application, so I don't even know how that works there. But yeah, that's basically about it. So smart data fetching and app startup, which falls under what we call TTI. And TTI is basically time to interactive. How much time does it take for a user to complete, a complete action? So let's look at an example here. User clicks on your website link. The page appears on the screen. Buttons and menus forms on the screen. And then eventually everything becomes responsive. So the user can click a button, they can browse. How much time has it taken for all that to happen? The sweet spot is 2 seconds. So it should take 2 seconds for your website to load the contents and make, and up to that point where the user can interact with your content, it has to take 2 seconds. So that is the time to interactive. A lot of senior engineers use this to, gauge how fast and responsive their mobile apps are. So how you attain this, Facebook uses a lot of aggressive caching. If I open Facebook right now, if I just open it, I'm not even looking at it, but you have seen how long it has taken it to open. It's almost less than 2 seconds. Now, here's where aggressive caching comes in. I've opened Facebook and I've closed it, okay? Now, I will go and turn off my Wi-Fi. So I don't have any internet connection. My Wi-Fi is off, my data is off. Now I will go ahead and open Facebook. All right. So if I open Facebook, as you can see, there's data. So where exactly is Facebook getting that data from? Because we don't have mobile, we don't have internet connection, but Facebook has data. And as you can see, oh, I thought that's a Mac X. There's quite a lot of data here. And it can even play videos. If I go to Reels, let me see. If I go to Reels, as you can see, that video is playing. The next video is playing. The next video is playing. The next video is... Okay, the next one is not playing. So I have turned off my mobile internet. I have turned off my Wi-Fi, but Facebook is still able to load data. It's because Facebook uses what you call caching. So the moment you're using Facebook, it's not asleep. In the background, a lot is happening. Facebook is fetching data and storing that data. It's storing that data on your phone. All right. So as you continue to browse, it's fetching more data in the background, but not the data that you need to see at that particular time. So that is on, caching. Another thing is payload minimization, and I've talked about this. I've said if you are loading the author's name in the homepage, Do you query the profile information and get everything and then just filter and display what you want, or are you fetching the information that you need? And then you also have lazy initialization, which basically, if you are using an external tool like M-Pesa like Paystack SDK. I know when I mentioned Paystack, Africans, Kenyans want to cry. So all these dependencies that are not required when a user opens the app, you don't need to load them. You need to load them in the background, which is what you call lazy initialization. All right. So how do you diagnose your app if it's not performing well? Number one is to check if it has any CPU issues. Is there anything in particular that is eating a lot of CPU? Check GPU issues. Is there anything that's using a lot of GPU? And also check memory issues. Depending on the language you are building your app in. If you're building in Flutter, we have what? Let me just scroll to where we have this. It's called Flutter Flutter Dev Tools, which basically gives you information about your what you call widgets. So if you've worked with React, if you've worked with React Native, in Flutter we call them widgets, which is basically reusable components that you can use and that you can reuse and you can use to structure your Flutter project. You can also run your code, your Flutter with this flag. Again, if you're using React Native, I'm pretty sure there is a similar command in React Native that you can use. And the other thing we can do to optimize our Flutter apps is to optimize our widgets. Like I've said, Flutter uses what you call widgets, and there's an example here. So if you use a list view, which is a list view builder, it's different from when you're using a grid view, because in grid view only visible items are rendered and destroyed on scroll. So as you scroll, the things that are out of your display will be destroyed. You don't need them. You don't need them to eat up your CPU and your GPU, as compared to if you're using a list view. But in some cases, you might want to use a list view, because if you're displaying information that is, not that big, for example, in the profile section, you might want to use a list view. Again, like I said, don't worry about list view and grid view and whatnot, because all this information, the AI can take care of all this. You just have to know what to tell it to do. So, for example, if your homepage is a little bit sluggish or it's a little bit slow, you have to start the diagnosis. Is it CPU? If it's CPU, what exactly is affecting the CPU? Am I drawing everything over? Or am I drawing only the parts that I need? And in terms of drawing only the parts that you need, where is rendering? My goodness, I had some notes here. Yeah, I have this very nice example to showcase. Okay, this is Obsidian, and somehow I cannot zoom. I don't know where to zoom from, but I hope you guys can see. So we have two pieces of code, which basically draws the user profile on the screen. So as you can see from this React Native code, this is React Native, we are displaying the screen container, which will display the entire screen. And then we have the card container, which will display, I think it's the name. And then we have the header strip, which is at the top there. All right. Now, if you look at the style, we have the screen container background, which will paint the background of the container. And then we have the card container, and then we have the header strip. All right. So if you look at it, this is how it will look like. All right. So you have the header strip, this one right here. It has its own background. The screen has its own background. And then the information you are displaying, the profile name or whatever they have, it has its own background. So as you can see, your phone is drawing 3 times. It's drawing this one, and this one at the same time. So if somebody is just viewing the profile, your screen has gone through 3 steps to draw the background only. How you optimize that is you only draw the background of the information you want to see on the screen. And I've shown you by this, and I've also shown you in code. I will combine these notes and share it on my Summer Stories blog for you guys to have a look. I think I've attached the link in the description of this video. And that's basically it. I wanted this to be a very brief session so that it can serve as an eye opener. It can serve as something you can use to dive deeper into your app's performance. So if you are displaying the profile page, you need to ask yourself, how much data am I fetching? All right? Am I fetching only the data I need, or am I fetching a lot of data and then just displaying the parts I need? How am I drawing on the screen? Are there any layers stacking on top of each other whereby the layer below is redundant, it's not needed, and things like that? These are the questions senior engineers ask themselves when they're developing apps. You see, if you're a junior, all you care about is it displaying the content? Perfect. Can I click this button? Perfect. But for a senior engineer, they ask themselves these questions. If I click this button, how much work am I giving the CPU? And things like that. Yeah, that's about it for this session. Oh, Amir, is that on React Native? I'm guessing that is on React Native. I haven't worked with dev before, so I think I'll need to explore on that. Yeah, that's basically it. I will see you guys next Saturday. We will find something else to do next Saturday. I've been thinking of having a fresh new course from scratch, which we'll call it Build with AI, which basically involves what we've just talked about, having that senior engineer mentality, but using AI to help you, get to production fast. I actually learned this. The presentation slide. Okay, yeah, sure. I will share it on the WhatsApp group. I hope you're there, and on Discord as well. So some of these things I was not taught, and sadly enough, there is no course that tells you all this. If you are learning about mobile development, there is no course that shares all this information with you. They will just tell you this is how you fetch data, this is how you display data, but they will not tell you, if you are fetching data, are you fetching the data you need, or are you fetching excess data? All right, they'll not tell you that. And some of these things I learned when I was building Soma Stories. Fun fact: Soma Stories was actually built in 3 months. In 3 months, I had deployed it. It was the MVP version, but it's not what it was when I deployed it. It is not what I deployed, what it is when I deployed it. There's quite a lot of changes that have happened. I've made changes to how I'm doing caching. I've made changes to how I'm handling background tasks and all those things. So a lot has changed. Amir, I think the one on my bio works. So let me just share it here again. I see Brooklyn Boys have dropped another song. That is what I'm listening to right after this. So let me just get you the Discord link. All right. I think the link I've shared in the chats will work. If it doesn't work, just let me know. Collins Odiera. Yeah, there's no giving up. I like that. Presentation slide. Collins, I will share that on Discord and on the WhatsApp group. That's it. I will see you next Saturday. Goodbye. Ooh, sir. Ooh, sir. Ooh, sir.